Okay, so first of all, with this one here, the area of this enclosure is 720. Okay, that will be the info to get, x and y in terms of the same thing, or y in terms of x. We notice here that this fence has got fencing all the way along there, and we'll call the length of the fencing y. Our whole aim is to use the wire, but not on the existing boundary, because we don't have the existing boundary as a fence, to get everything in terms of x. So at the moment, the length of the boundary would be 1, 2, 3, 4, 5, x plus y. Okay, so the length of the boundary then, we need to now work out how to get y. So to get y, we then need to say, okay, the area is 720. So xy equals 720. So y is 720 on x. And then what we need to do is we get the 720, and we need to plug it into length equals 5x plus y. So length is 5x plus 720 on x. And if you look at this here, okay, there you go. That's exactly the same thing. All right, so the next step now is the calculus part. Find the minimum length. So we're after a minimum here. So we need to differentiate, and we have to show why it's a minimum. So that's like your A double dash stuff. Okay, so we need to go, that's 5x plus 720x to the minus 1, because it's a power of 1. L dash would be 5. Bring the minus 1, minus 720, take 1 away is minus 2. 720 on x squared. Make x dash equal 0. 5 minus 720 on x squared equals 0. 5 equals 720 on x squared. That means you'll have 5x squared equals 720. I'm just going to go to that. X squared is 720 divided by 5. Okay, 720 divided by 5. We get 144. So then when you square root that, you get plus or minus 144. But because it is a length, I'm only going to take the positive 12 because it is a length. Okay, so the actual question says what? Find the minimum length. So I've got the length. What we have to then do is check it's a minimum. So you have to check it's a minimum. So that means you have a choice. You can do it with the L dash, or you can do L double dash. Now L dash is 5 minus 720 x to the minus 2. So to get L double dash, the 5 will go to 0. 720 times minus 2x to the minus 3. So 2 lots of 720, 2 lots of 720 is 1440 x to the minus 3. So you get 1440 on x to the 3. So we want to do that when x equals 12. So L double dash is 1440 on 12 to the 3, which is greater than 0. Okay, so it is a minimum turning point. Okay, so we've proved it's a minimum, and we've also got, we want to get the minimum length of wire. So x equals 12 isn't actually a length, that's when it occurs. So I'm then going to have to put it into the length formula. So the length formula is what? 5x minus 720 on x. So that means that's going to be 5 times 12 minus 720 on 12, 60 minus 720 on 12. 720 divided by 12, we get 6. That doesn't work. Let me just have another think about that. Let me have a look here. Yeah, I'll put 12 in there. 720 on 12. 5 times, it should be a plus in the middle. That's what I've done. It's a plus in my formula. Silly me. That's a plus. That's a plus. Okay, so that's going to be 60. So you end up with 120 meters of wire for it to be a minimum. And there's the solutions there you can look at as well. Okay, so the next one. All right, so looking at this here. So we have show that P equals that. So P is your perimeter. So your perimeter would be X plus Y, so X plus Y, plus whatever that arc length is. So if the radius is X, the arc length would be 1/4 times 2 pi R, and R is X. So that's going to be 2 pi X on 4 or pi X on 2. Yeah, that's good. So it's going to be plus pi X on 2 plus, got to go X plus Y. So the perimeter is 2y plus X plus pi onto X. Okay, so we've done that part of it. Now, this is in terms of X and Y. So technically, I've got to get rid of that Y. Okay. So let's just have a quick look. I just want to double check too. The perimeter is X and this X. So I've got X. So it should be 2x's, shouldn't it? 2x, yeah. So the perimeter is 2x plus 2y plus pi onto x. This is 2y's, 2x's, and then that. Okay, so you've got your perimeter. That's all good. So I've got it in terms of y. So what other information have they given you? They've given you the area. So the area is 36. So that means that one area is x times y, that's that part, plus 1/4 times pi times r squared. That should equal 36. Okay, so we're going to use this information to help us get something for y. Okay, so we go xy equals 36 minus 1/4 pi x squared. Y is 36 on x minus 1/4 pi on x squared on x. So I'm just dividing everything by the x. So y is 36 on x minus pi x on 4. So there you go. That's y in terms of x. So now all I need to do, if I've got my perimeter, which is sitting up the top there, then my perimeter is 2x plus 2y plus pi onto x. And I am subbing in to my y value, the thing that's above. 2x plus 2 times 36 on x minus pi x on 4 plus pi onto x. So I'm just going to focus in on that. So that's 2x plus, if I open the bracket, 72 on x, because it's like multiplying by 2 on 1, minus 2 pi x on 4, because 2 pi x and 1 times 4, plus pi x on 2. Okay, so that's 2x plus 72 on x. Now you've got minus 2 pi, that will go to a half, won't it? So that is going to be minus pi x on 2 plus pi x on 2. Do they go out? And you get 2x plus 72 on x. Yay, magic. So that works out. So we actually get what we want. Okay, now that's not where we end. That just answers this part here, part A. What we now do is we need to find out where is the maximum or minimum. So do you notice in here, what they've done here, we're finding P dash. So I'll just get rid of that part so we can do it our way. So if we go P dash, so this is P, P equals 2x plus 72 to x to the minus 1. P dash, the 2x goes to the 2, minus 1 comes down to give you the minus 72, and take 1 away, 72. And P double dash, the 2 will go to the 0, plus 144 x to the minus 3. Okay, so in order for a maximum or a minimum, what do we have here? Maximum or a minimum. Let's go P, no, sorry, start again, get a smaller one. P dash has to equal 0. So that's 2 minus 72 on x squared equals 0. So when you solve that, bring that over there. So you get 2 equals 72 on x squared. If you cross multiply, you get 2x squared equals 72. Divide by 2. Divide by 2, you get x squared is 36. And then square root it. So it gets 6. And x is positive because it is a length. Okay, if you want to check that it's a maximum or minimum, you need to then put it into P double dash. P double dash. So P double dash was, now we found it up here earlier, 144 x to the minus 3. 144 x to the minus 3. So it's 144 over x cubed. So if you put in a 6 there, you can see that that is positive, therefore it is a minimum. So to make sure we answer the question says find the smallest possible perimeter. So we actually have to sub it in to find P and explain why it's a minimum. Notice that this HSC question is worth 4 marks. 1 for finding P dash, and 2 for solving. 3 for determining that it is a minimum, and 4 for answering the question and finding the perimeter. So always look at your marks. Okay, so once you know it's a minimum at x equals 6, you put it into the perimeter formula, which is this, which we derived before. So it's 2 times 6 plus 72 on 6, which is 24. And that's the perimeter that is a minimum. Okay.